a distance problem. So remember, rate times time equals distance. So, and we're in chapter 4, so, you know, we can use two equations. Some of these videos I didn't use two equations, I just used one, but the concepts were implied that there was a second equation. You really can do it whichever way works best for you. So don't think that, oh my gosh, she's in chapter 4 and she only uses one equation and the world's going to fall apart. It's okay. Some of these problems can be done that way. It's just a matter of what tools you're going to use and how you see the problem. So, but sometimes it's definitely easier to use two equations. Okay, so distance problem, rate times time equals distance. Remember to take your time with these problems, enjoy them. You're not trying to rush through them, you're just trying to figure out what's going on. Okay, so Mitchell left Detroit on the interstate driving south towards Orlando at a speed of 60 miles per hour. Okay, so here's Detroit. I'm from Michigan. Okay, well, I shouldn't have said that after drawing that lousy map. Okay, but there's Detroit, approximately, and he's going down to Florida. We're going to do worst drawing Florida. Okay, I don't know how to draw the United States. Okay, and Florida, there, it's down there. Anyway, Mitchell leaves, and he's traveling at 60 miles an hour. Okay, Clark, give Clark a green color. Clark's going to leave an hour later, and he's going to go 75 miles an hour. Following the same route as Mitchell. How long will it take Clark to catch Mitchell? Okay, so Mitchell, color coordinate it here. So Mitchell's going, the distance is going 60 miles an hour for so much time, we don't know how long, and he's going to go so far, some distance, okay? So kind of you don't know a lot about Mitchell. All you know is he's going at 60 miles an hour. We don't know how long he's traveled. That's kind of what we're trying to figure out, but he's going to go so far. Like if he drove for 3 hours, he'd have gone 180 miles. If he drove for 10 hours, he would have gone 600 miles. Okay. Now, Clark, same situation, except Clark's going faster. So he's going for 75 miles an hour. Now, I'm going to come back to I'll talk about it right now, the time. He doesn't travel the same amount of time that Mitchell does because he leaves an hour later. So his time, if Mitchell's time is t, then Clark's time has to be t minus 1. Okay? And then he's going to go a certain distance. And we want those distances to be the same because we're trying to figure out how long it's going to take Mitchell or Clark to catch up with Mitchell. Okay? So those D's, the distance that they each travel in our situation, so they're going to, here's Mitchell driving, and then here's Clark starting a little later, and he's going to try to catch up. And at some point, because Clark's going faster, they're going to catch up and they'll be at the same point. And then that would be the D. Okay. Hopefully that made sense. You can think about it. Stop the video, think about it a little bit. Okay. So we want to know, when does 60t equal 75 times t minus 1? Now, why is it t minus 1? Because remember, Clark left an hour later. So if Mitchell traveled 3 hours, then Clark's only traveling 2 hours. If Mitchell traveled 10 hours, then Clark's traveling 9 hours. And what we're trying to figure out is how long Mitchell needs to travel and Clark needs to travel to get to the same point. Okay. 60t equals 75t minus 75. So that's some distributing there. And I'm going to go ahead and subtract the 75t. I know some people have learned, try to keep your variable positive, and that's true, but I'm just going to do it this way. The negative doesn't bother me, hopefully. Now, if I get a negative time, that's going to be a problem because we're not going to go backward in time in this problem. So, okay. So we've got a negative 15t on the left, and then we've got that negative 75, which is coming from right there. Okay, that's where the negative 75 came from. These canceled out. Okay, divide by negative 15. And so the time is going to be, well, how many times does 15 go into 75? 5 times. Double check my math. Yeah, it's positive. Negative divided by negative is positive. So looks like we have 5 hours. Now, I got to be a little bit careful because my t was how long Mitchell was driving, right? So Mitchell drives, note to self, Mitchell drives, call Mitch, 5 hours. But how long is Clark driving? An hour less, so 4 hours. So now what's the check? If Mitchell drives at 60 miles an hour for 5 hours, that's 300 miles, right? Okay. If Clark drives 75 miles an hour for 4 hours, that's also 300 miles. So that's how he caught up. So it's going to take Clark 4 hours to catch up. So the question was, how long will it take Clark to catch Mitchell? 4 hours. Clark will catch up in 4 hours. It's going to take him 4 hours to catch Mitchell. All right. A little tricky.